All right, we're here to talk about one single molecule, dopamine. But hold on, because this is not the story you think you know. We are about to dive into some absolutely groundbreaking new science that's going to change everything you thought you understood about how your own body works.
For decades, you've heard this simple story, right? Dopamine is the happy chemical. It's that little reward your brain gets for a good meal or a lucky win. It's been painted as this simple, one-note molecule. But what if I told you that simple story isn't just incomplete, it's fundamentally wrong? I mean, recent breakthroughs are revealing a system so complex, so powerful, that the whole feeling good idea doesn't even begin to scratch the surface. So first things first, let's just shatter that old myth. We have to move past the pop science version to see what the new research is actually telling us.
Okay, to understand what dopamine really is, we have to see it as a precision chemical. We're going from this fuzzy general idea to a super high-definition picture of how it actually operates inside the brain. This slide right here, this really gets to the heart of the whole shift in thinking. The old idea was this broadcast model, that dopamine just washes over big chunks of the brain like a radio signal. But the new hotspot model shows us something way more elegant. Think of it less like a radio and more like a hyper-efficient postal service, delivering very specific messages to very specific addresses at exactly the right moment. And those delivery points, while scientists call them hotspots, these are tiny, super concentrated zones of communication. So it's not about flooding an entire neighborhood with one message. It's about a direct, private conversation between two specific nerve cells. And that allows for an unbelievable amount of fine-tuned control.
And the specialization doesn't stop there. Get this, the brain actually has two different dopamine systems that work together, kind of like an actor and a critic. The actor system is all about the doing. It's what sustains the physical effort to make you move. But before the actor can do anything, the critic system has to step in and answer one crucial question. Is this even worth it? It evaluates the potential reward and generates the motivation to act in the first place.
So think about that for a second. The critic is literally the thing that gets you off the couch. It's the part of your brain doing the math on a goal's value and giving you that internal push to go after it. This gives us a brilliant new insight into diseases like Parkinson's. The apathy some patients feel might not be a failure of the actor to move, but a failure of the critic to even give the green light.
So when the critic is making that calculation, what's it weighing most? I mean, just look at this chart. It is not even close. The signal for the future reward, the wanting part, is massive. The anticipated effort, that's tiny little factor in comparison. This shows us so clearly that dopamine isn't really about the pleasure of having something, it's about the intense motivation of wanting it. And it gets even more nuanced. You see, dopamine isn't a one-trick pony. It sends at least 3 distinct types of signals. You've got the value signal we just talked about, that's the classic reward signal, but there's also a salient signal, which is more of a general, hey, pay attention to this kind of nudge. And fascinatingly, there's also a pure alerting signal, a little burst of dopamine just to say, whoa, something new is happening here, whether that something is good, bad, or totally neutral. So we've established that dopamine is a precision tool in the brain. But this is where the story takes a truly shocking turn. We're about to zoom out, because the latest discoveries show that dopamine's influence goes far, far beyond the brain. It affects our entire body. Seriously, prepare to be surprised. We're about to uncover dopamine's secret life as an emotional gatekeeper, a commander of your immune system, and yeah, even a cancer fighter. Let's start with your emotions. Deep inside your hippocampus, a key area for handling stress, dopamine acts as a crucial tiebreaker. Imagine you're facing a tough choice, something you both want and fear at the same time. It's dopamine that steps in to help you make the final call. Do you go for it or do you back away? And how does it do this? By using 2 different types of receptors that act like a gas pedal and a brake. Activating your D1 receptors, that's like flooring the gas. It pushes you to approach. But activating your D2 receptors hits the brakes, pulling you to avoid. It's just this elegant, balanced system for navigating life's difficult decisions. Now, for what might be the biggest paradigm shift of all. It is official. Dopamine is a key player in your immune system. That's right, your own immune cells, the very things that fight off infections, are covered in dopamine receptors. They are literally listening for instructions from dopamine. And we're not talking about some minor connection here.
Problems with dopamine signaling are now directly implicated in a whole host of major diseases like MS and rheumatoid arthritis. This idea that our brain's motivational chemistry is deeply wired into our body's defense system is, well, it's truly revolutionary. And maybe the most astonishing discovery of all is dopamine's emerging role in oncology. That's right, fighting cancer. New research is showing that this one little molecule can attack tumors through at least 3 distinct and powerful mechanisms.
So, how does it work? Well, first, it literally starves tumors by stopping them from growing new blood vessels. Second, it can directly trigger a self-destruct sequence inside the cancer cells themselves. And third, it calms down the chronic inflammation that helps tumors grow in the first place. It is a powerful 3-pronged attack. So what does all this mean for the future of medicine? I mean, this complex new understanding isn't just an academic exercise, it's paving the way for a total revolution in how we actually treat diseases. Let's just look at mental health. We now know that abnormally high dopamine isn't just linked to, say, schizophrenia. It's a biological marker for psychosis itself, no matter what the specific diagnosis is. Whether we're talking about bipolar disorder or severe depression, if psychosis is there, that underlying dopamine issue is often the same. This is the dawn of something called precision psychiatry. Imagine, instead of treating a broad label like depression, doctors can target the specific biological issue, like elevated dopamine. We can start treating the broken circuit, not just the symptom list. You know, this timeline really brings our whole journey full circle. We started back in the 50s thinking of dopamine as just a motor chemical. Then came all those decades of the pleasure chemical myth. Today, we finally see it as a precision neuromodulator. But the future? The future points to something even bigger, dopamine as a master regulator of our entire body's health. So if you take away just one thing from all of this, let it be this. We have to forget the idea of a simple, happy chemical. The true story of dopamine is so much more incredible. It's the story of a precise, powerful master regulator that is woven into the very fabric of our minds, our bodies, and our health. And that just leaves us with this one final, fascinating question. The story of dopamine proves that a single molecule can hold secrets we never, ever imagined. It really makes you wonder, what other profound truths are our own bodies hiding from us, right there in plain sight, just waiting to be discovered?